In this video, we will be looking at what similar triangles are and how to prove their similarity. So we're going to start off with a little visual. I have triangle ABC with side lengths 10, 8, and 6 and the following angle measurements, and triangle JKL with side lengths 5, 4, 3 centimeters and the following angle measurements. So I'm going to start off with an observation about the angles. If we look at our angles here, angle A matches angle J. Angle B matches angle K. And angle C matches angle L. So in similar triangles, the angles match. So the corresponding angles are equal to each other. Let's look at our side lengths. We have a 10 centimeter and a 5 centimeters, an 8 centimeter and a 4 centimeter, and a 6 centimeter with a 3 centimeter. It looks like if we just take the smaller triangle, so triangle JKL, and multiply all of the side lengths by 2, so double them, we're going to get the side lengths from triangle ABC. 5 times 2 is 10. 4 times 2 is 8. 3 times 2 is 6. We can also go in the other direction and cut the sides from ABC in half. So I could also divide by 2 to get to the smaller triangle. So it looks like there is a scale factor. So if I multiply or divide one triangle by the scale factor, I will get the other side lengths. So I'm just going to make a note that one triangle is half the other or double the other, depending on the direction you look in. And I'm going to make a note that corresponding sides are connected by a scale factor. So that value of 2. Let's look at the scale factor in a little bit more detail. So here we are told that triangle UVW, and then this notation here, the single squiggle, is stating that the triangle is similar to triangle XYZ. If the scale factor is 2, determine the side lengths of triangle XYZ. Okay, so first we want to see which triangle is bigger. So definitely XYZ is bigger, and it is double the length of UVW. So we want to take all the side lengths and multiply them by 2. Now I'm choosing multiplication here because multiplying by 2 will give me a bigger side lengths. Technically we can also divide by the scale factor, but if I try to divide these side lengths by 2, I will get smaller dimensions, which wouldn't make sense in this visual. Now, first thing we have to do is identify which sides correspond. And if we look at our previous example with the visual, the sides that matched had the matching angles as well. So if we look at the 6 centimeter and the 3 centimeter side length, that side is created by the 60 and 80 degree angle, and same thing in the smaller triangle. If we look at the 10 and the 5, they're both created by that 60-40. So when I look at this example, it's already nicely set up for me, but if I look at WV, it matches Z and Y because both of these side lengths are created by the single tick mark angle and the 3 tick mark angle. Then the 5, so WU, is going to match ZX, and then the 3 is going to match XY. So these two triangles were nicely positioned. So let's start with the blue pairing that I have here. So side ZY is going to equal 4 times 2, which is 8 units. So I just doubled to get here. Let's look at 5 and trying to get side ZX. So ZX has to be double 5. So 5 times 2 is 10 units. And finally, to get XY, we're going to take the 3 and double it. So 3 times 2 is 6 units. So in this scenario here, we had to multiply by the scale factor to get the bigger side lengths. Let's try another example. So here I am telling you triangle PQR is similar to triangle STU. Now I didn't put any angle notation here, so I'm just going to kind of go based on the orientation. So the 12 here is going to match SU. RQ will match UT, so the base goes with the base, the height with the height. And then this kind of looks like the hypotenuse of a right triangle, if it were a right triangle. So I see how everything matches. Now I'm told that my scale factor is a third. I have to decide if I should multiply by a third or divide by a third to get a bigger side length. So for something like this, you might have to do a little bit of trial and error, especially when a fraction is involved for the scale factor. So let's say I'm trying to get SU. So the 12, something has to happen to it. I haven't decided what. Let me try 12 times 1 over 3. When I do that, I get 4. That doesn't make sense because triangle STU is bigger and 4 units is smaller than 12. So just using that trial and error scenario, I know that I should actually divide by my scale factor. So let me see if that makes more sense. 12 divided by 1 over 3 is 36. That makes sense. So sometimes you have to try both options. Okay, let's look at the 9 units, trying to get UT. So once I choose division, I'm doing division the whole way through. So I'm going to do 9 divided by a third. And if you try that in your calculator, you get 27 units. And finally, the 15 to get side ST. So 15 divided by a third, and we get 45 units. So this is just a little sneak peek to the scale factor and trying to find the side length. This isn't how we're going to solve in the future, but just to familiarize ourselves that one triangle is a multiple of another, whether you're doubling or you're dividing by a third, whatever it may be. All right, so 2 triangles are said to be similar if all their angles are equal to each other, so the corresponding angles match, and that the corresponding sides are related by this scale factor. There are 3 different ways to prove that 2 triangles are similar, and the method you use is going to depend on what is given to you, because you're not going to be given all the angles and all the sides of your triangles. You might just be given some of the information. The easiest proof is the angle proof. So if you're given 2 angles in each triangle, if you can show that 2 pairs of angles are equal to each other, then the third one automatically matches as well, because we know all 3 angles in a triangle have to add up to 180. So let's look at this little example here. Using the notation, the fact that you have these 2 tick marks for U and X, that means angle U is equal to angle X. And then I have 3 tick marks for V and 3 for Y, so that means angle V is equal to angle Y. And the minute you have this information, your third angle, W and Z, they're gonna match. I like to write all 3 equal angle pairs. Once you write that, that's you proving that the angles are equal. The minute the angles match, the triangles are guaranteed to be similar. After you do that, you're going to write a similarity statement. So angle or triangle UVW is similar to, so that squiggly single line there is similar to, and now the order that we write the letters for the second triangle is going to be really important. So we have to make sure that when we write the three letters, the corresponding angles are in the correct position. So angle U was equal to angle X. So I'm going to write that first. Angle V was equal to angle Y. And W was equal to Z. So this is your similarity statement. Triangle UVW is similar to triangle XYZ. Sometimes you might be given two side lengths and the contained angle. If that's given to you, we are doing the SAS or SAS proof. To prove it, you have to show that the contained angle is equal. So in this case, we have angle R and angle A. So I'm going to state that. And I have to show that the corresponding sides have the same scale factor or the same ratio. So you have to do a little bit of guesswork and see which sides you think match. First of all, I don't think the 6 matches the 6 in the other triangle. These triangles are not identical, they're just similar. So I think the 6 will match the 4, and as a result, the 9 will match the 6. To prove that they have the same scale factor, I'm just going to divide the side lengths. So 6 divided by 4 for the first pair, that is equal to 1.5. 9 divided by 6, also equal to 1.5. The fact that these match, that's your scale factor. You've just proven that two sides correspond and the contained angle or the middle angle, they are equal. And that's enough to prove that your triangles are similar. So again, I need to make sure that my letters are in the right position for my similarity statement. So I know angle R matches angle A. So that's the first letter I'm going to write. After that, I'm going to pick one of my sides. So let's say side RT. The 9 matches the 6. And the 6 is made up of AF. So I'm going to match the T with the F. And then I can just put my last remaining side. So AFC. So this scenario is when you have two side lengths and an angle. And the angle has to be the one sandwiched between your two side lengths. And the last proof is if you have absolutely no angle, but instead you have all three sides given to you. What we have to do there is pair up our sides, so the sides that we think match, and then show that fraction like we did above 3 times. And the scale factor should match all 3 times. If it does, they're similar. If it doesn't, they're not similar. So looking at this, I'm going to do a little bit of a preview here. I have side lengths 3, 4, 5, and 6, 8, 10. It kind of looks like the triangle's being doubled, and that's what I need to prove. So I think the 4 and the 8 match. Actually, I'm going to show it as a line. So 4 and 8. I think the 3 goes with the 6, and the 5 goes with the 10. And you have to prove it. You have to show some math. So let's start with the green pair. The order that you divide your side lengths doesn't matter. Just be consistent. I'm going to do the big triangle over the small triangle. So 8 divided by 4 is 2. My blue pair, 6 divided by 3 is 2. My red pair, 10 divided by 5 is 2. The numbers all match. This is similar. That's all the work you need to show to prove that it's similar. And now we write our statement. And we have to be careful here. We don't know which angles are equal to each other, but we can get a little bit of an idea based on the matching sides. So let's say angle F here. It's made up of the blue and the green pair. Here's the blue and the green pair. That means F matches C. So here's F, I'm going to put C. Next, let's look at B. B is made up of the blue and red line. E is made up of the blue and red line. So I'll put that next. and then the last letter automatically goes in. So FBD is similar to triangle CEA. So those are our three methods for proving. Now let's try it out properly and decide which rule to use when. In this example, we're given 3 sides in each triangle and no angles. So right away, I have to use side, 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 because there's no other information given to me. So let's do some guesswork. Let's look at the big picture here. I have 6, 7, 11, 18, 21, and 33. Sometimes just by looking at it, you might already see what the scale factor is, and you can match up the sides nicely. If you can't, just use the visual to try to guide you. So for me, I think the scale factor, just by looking at it, it looks like triangle ABC is being tripled to get DEF. So I think 6 and 18 match, because 6 times 3 is 18. I think 7 and 21 match, because 7 times 3 is 21. And I think 11 and 33 match, because again, 11 times 3 is 33. If you don't see that right away though, it's okay. We're gonna show it mathematically anyway. And at the beginning, you can kind of do a guess and check. All right, so using my matching pairs, I'm gonna show my 3 fractions. That is the work that is required. And I like to divide big divided by small. So 18 divided by 6 for my blue pair is 3. Okay. My red pair, 21 divided by 7 is 3. Okay, same factor. And 33 divided by 11 is also 3. So when you do that, you're proving that each of those numbers in triangle ABC, they were all multiplied by 3 to get the other one. You can't have one side being multiplied by 3, the other by 2, the other by 4. If that were to happen, these are not similar triangles, but these do match. So now we write our statement. Triangle. For the first one, you put your letters however you want. Similar to triangle. Okay, let's match up our sides or our angles. A. Well, it looks like the triangles are oriented in the exact same position, so A does match D, but you can also see it based on the colors. They're both made up of the blue and red. So I'll put D first. Let's look at B. B and E match. They're both made up of the blue and green. And then F is going to go next. And this is exactly what you would be showing. The type of proof you're doing, your 3 calculations, and your statement. Okay. Let's try another one. So I have triangle ABC and triangle DEF, and I have some angles given to me. Right away, I see A and F match. And I see all angles given, no sides, so I'm thinking this is the angle proof. So angle A equals angle F. And then I notice the other pair of angles that are given to me, the 80 and the 30, they definitely don't match. So sometimes you might have to do a little calculation to find the third angle. We know all 3 angles should add up to 180. So I'm going to do 180, subtract 70, subtract 80, and I get 30 degrees. Okay, wonderful. That means angle B and D match. And then I can do another calculation to solve for angle E and the other triangle, but the minute 2 angles are equal to each other, the third set has to be equal as well. And what's really nice about your angle proving is when you write the similarity statement, I literally just take the order of these letters. So triangle ABC is similar to triangle exactly how I wrote it here, FDE. Because when you wrote these statements, you already showed which angles match. So if you write them in the exact same order, A goes with F, B goes with D, C goes with E, exactly how we wrote in our statements. And again, here's how I did the proof. Here are my 3 statements, And here's the similarity statement. In the next example, I have a mix of sides and angles. When that happens, it's probably side angle side. And it is because I have two sides and I have that angle that the two sides make. Okay, so this is SAS, side angle side. I like to do the angle first. A matches X. Okay. I don't know any of the other angles and I can't just assume that, oh, I think B matches Z or Y. I can't assume that. I can't make those assumptions, so I have to use what is given to me. I'm given 15 and 21 in triangle ABC and then 10 and 14 in the other one. So I think it makes more sense for the 15 and the 10 to match, and then the 21 is going to go with the 14. Okay, so let's see if I'm right. For our red pair, 15 divided by 10 is 1.5. And for our green pair, 21 divided by 14 is also 1.5. So there we are. They match. So in this scenario, I had to show one angle and then two sides. Okay, triangle ABC. We know A matches X, so I'll make sure A and X go together. Now B is going to match the other angle that makes up the red pair, so that's Y. And then Z would go at the end. Okay. Our last two examples, it looks like you are given absolutely nothing. We don't have any angle notations or any angles, and we don't have any sides. However, we are told that we have these two sides that are parallel. And when you see that notation for the parallel, which is these little arrows, that means you're going to use some angle properties to show that angles are equal to each other. And as a result, we're using the angle proof, which I like this one the best. Okay, in this orientation here, we have two triangles, ABE and EDC. I'm going to do a Z pattern because I see this zigzag motion here. So if I do my Z pattern and I draw a Z like this between my parallel lines, then angle B matches angle C. So I'm going to make a note. Angle B matches angle C. I'll do another Z pattern, but the other way around. And when I do it like that, angle A matches angle D. And if I want to use different notation, I can put like 2 tick marks to show it. And, you know, the minute you have two angles that are equal, the two angle E's equal as well. So the E in this triangle and the E in this triangle. And then when we write our statement, I'm going to put BAE, similar, CDE. Go in the exact order if you don't want to mess it up. And there we go. So in this scenario, whenever you have this zigzag, you're going to use the Z pattern. And the next one, again, no sides, no angles, but we do see these parallel side lengths. And here I don't see any zigzagging, so we're going to use the F pattern. So if I do an upside down F here, then B and D are going to match. Actually, before we even look at that, we should see what our triangles are. We have this little triangle here, ABC, and then this giant triangle on the outside, ADE. So that's what I'm comparing here. I'm going to do another F pattern here. So in this case, C, I'm going to do 2 tick marks, goes with E. And then automatically, A is in both triangles. So A goes with A, because that is the top of the triangle in the little one, ABC, and the big one, ADE. So this was an angle proof. And our statement is that BCA, because that's the order I wrote it in, is similar to DEA. And that's it. So if you're outright given the angles, like we were here, you just state those equal angles, and sometimes you might have a little calculation to do. If it looks like you're given nothing, you see this zigzag or this triangle within a triangle, you're gonna use some angle patterns. If you're given a mix and match of sides and angles, we have SAS, side angle side. And finally, if you're given all three sides and nothing direct about the angles, it has to be a side. So anything associated with sides, you have to show that little fraction to get your scale factor. If it's just about angles, you're just showing which angle is equal to the other. And that's it for proving similar triangles.